equation. Set my marker down. But before I do, let me just mention what an inequality is. Like x is greater than 2, it means a bunch of stuff. More than just one answer, like when you say x equals 2, that's all it is. X is the number 2. But when we say x is all the numbers, think of it as being saying all the numbers greater than 2, which is a bunch of stuff. Not just 3, 4, 5, and the integer numbers, but it's also the little fractions and decimals, everything in between it, right? So to show that, you can never write all those numbers out, so we can oftentimes use different notations to demonstrate that, like the number line. So we'll say, here's 2, x is all the things on the number line, so just kind of darkening in the whole thing to show it's all the little pieces greater than 2. If it says to write it in interval notation, that means how far does it go to the left, 2, and notice I have a parenthesis on this because I'm not including the 2, and that's the way that we demonstrate just up to 2, but not including it. So parenthesis 2 to comma to the right, that's going to a positive infinity. And we always use a parenthesis on infinity. Another example, if I said x is all the things less than or equal to -3, to demonstrate that on a number line, I would use a bracket on the -3 because it has a line under it. I'm including the -3. And less than would go to the left, darken in the arrow even to show that it's going to that infinity. We'll call this direction negative infinity. So to the left, it's going to negative infinity, comma, to the right, -3 with a bracket. That's the interval notation they're talking about. All right, so now let's solve a linear inequality. So just like always, I would isolate the variable by working around it, getting the variable alone. The only difference in a linear inequality and a linear equation is when you divide by a negative. Do y'all remember seeing this? When you divide by a negative, it flips that inequality sign around. So don't forget to do that. It's actually divide or multiply, which they're kind of sister operations there anyway. So dividing or multiplying by a negative flips the inequality sign around. So this becomes x is less than +4, which would look like this. Less than 4 goes this way. So we'd have negative infinity to 4 in interval notation. Okay? Another example, number 2. If you found me in your note packet, it looks like this. So I want to gather the y's. Now listen, it's up to you if you want to take your y's over to the left side or the right side. Just know on the inequalities, if you take your variable to the right side, you'll have to read it backwards because you read it from the variable's perspective. So I would be tempted to do that. I just want to demonstrate. If I bring the -3y over, it becomes +3y or 5y on the right side. Bring the 7 to the other side, makes it -3. You solve by dividing by 5. Do not flip the inequality. You're dividing by a +5. But like I said, you just kind of have to read it backwards. I know it looks like a less than sign, but read it from y's point of view. Y is greater than or equal to -3/5. You may just want to write it that way. Y is greater than or equal to -3/5. We could have went the other way and subtracted the 2y and solved it from that side, and then I wouldn't have to turn it around. So sure. So this is greater than -3/5 or equal to, so I use a bracket. Looks like that. Yeah, in your note packet, I did it the other direction. So that's why you see that's the same answer. Okay, do the U try. Number 1.